the device. It's not a real device, a virtual device, so it's not a big problem nowadays. Simple MS-DOS, complex Unix. I think that is the microkernel. Okay. MS-DOS, I don't think it's required or important nowadays to understand the structure of MS-DOS, but when you learn the computer stuff, such as the microcontroller or microprocessor, probably you learn about the 8088 or 8086, which is the old version. It's the same thing. So this is a very old fashion, but it's as you can see, this is the BIOS device driver. It's to access the system at the device. Okay, it do sometimes when the MS-DOS control this one. What about system program? Directly access. What about the application program? Even application program can directly access if there's a conflict, like in the memory. Especially in the memory, it's frequently happen. Why? Memory is the most expensive and very important, but it's a limited resource. So they need to definitely share the memory area that caused the conflict situation. Okay, the data supposed to be here, but the other process take that. Then it's a memory problem. So nowadays it's not very open, but when I use Windows 95 or 97, 98, so you can see some pop-up. It's a memory address, and this is not the accessible, something like that. Because of this kind of architecture, even application program directly access such a thing. Okay. This is MS-DOS, the command line interface. Anyone who ever used MS-DOS? How many of you use? Don't worry. Even though you do not use it. So Unix is the another operating system. It has the system programming. System program is included in the kernel program. So this is a history of the Unix system. So 1969. So it's 1969. What happened in the 1969? The Neil Armstrong went on the moon first time. It's in 1969. Also Dr. Yev proposed relational database model, okay, to the ACM, and also Professor Lee was born at the time. And also Unix, the first Unix was born, and there's in addition then there are two main categories. The branch of the Unix system. One is the Berkeley, another one is System R project. So is the HP Unix, the AIX in IBM, and IRIX. I never used that one, but Sun OS is still the Solaris version. I don't think we have the Sun Lab, but we had the several years ago. So these are from the System R project. System R, the Unix system, and another part is the Berkeley, and still many of the operating systems follow the such a Berkeley branch. So if you want to see the history of the Unix system, this is from the 1969. It's a page by page. So if you connect next to each other, it will be very long, the family tree for Unix. Okay. So, for example, 1980 we had BSD and I never heard 26 OS. I heard about it, and sometimes it's gone, sometimes still developed. So it's more complicated. 989. Ooh. You want some questions for your midterm exam from here? Those who memorize the family tree of the Unix, I will give the A. So let's take the recent one. So, 99, 2000, 2001, 2002, 2003, 4, 5, 6, 7. Some of them are already gone. You can see the one of the branch of the Unix system is Mac OS. So you can see the Mac operating system. Even iPod, from the iPhone, so it's coming from here, right? So, and also Solaris, Unix, AIX, okay? Mac OS. What is the current one? Yes, 2014. 13 and 14, you can see the iOS 7.4, OS X Mountain Lion, it's a 10.8, and Android 4 is a Gingerbread, and here, even the Solaris, actually the produced by the Oracle Corporation, is not, right now it's called Oracle Solaris, and HP Unix and the Linux. Okay, so actually I printed out this one and connect. So it's, I think the L is 10 feet. So think about it, it's a 33 pages for 8 inches, so 240 inches. Right. Also you can find more information about such a history of the computer. It's sometimes very interesting. So one time I asked the department, why don't we have something computer history class at the 1 or 2. I mean, it's not the research or the algorithm level course or programming course. It's just the understand the computer itself. Okay. Then who knows? Some of you guys are teaching the high school or the middle school for the computer science. At the time, this kind of history will be definitely effective to teach the kid. So traditional, the Unix system structure is like that. So there is the system and the kernel program, and there is the interface program, and finally user. User can access this one. But nowadays, the most of the operating system follow the layered approach. Layered approach is they pursue the small kernel as possible. One, if you put all the library, functions, system call, and even application into the operating system, it will be Windows. Okay, so that includes everything. So it is not easy to customize. You need at least certain amount of the resource, minimum specification of your hard disk drive to install them. Even though you are going to use this much of the functionality in your operating system. So to address the problem, layered approach is the first layer is definitely hardware. That includes some of the firmware, and layered one is the controller program or device program, and layer 2, for example, the kernel program, and so on. So as needed, you can add such a layer, so it will be the more effective. The problem is, probably the last layer, or most outside the layer, is a user. right? Usually I try to use the hardware. How can you communicate? And it's also allowed to communicate directly with the hardware, but that causes a problem. So you need to ask this layer, shell programming. Then this shell programming we call the inner layer and inner layer. So once you reach your command reach that hardware and execute and return. So that takes a little bit time. But still easy to manage and more secure. So that means it's a micro kernel. Micro kernel is pursued as small kernel as possible. Okay. macOS kernel is based on the Mahur, so that is I think the one of the user asked whether this is correct. Yes, I think so. There are several benefits. I think it's a straightforward. You can easily understand what is the benefit of such a microkernel. It's more secure and easy to extend and easy to customize and more reliable because it's small. And also, one of the current trend, popular trend of the operating system is modular. Modular means, unlike the Microsoft operating system, they put all the product, all the thing, even unused one, into the one operating system. On the other hand, we are going to set as a module. Like this module is for expertise, while this module is for the general user. So this module is for file system. So if you need advanced level of the file system, you need to purchase. Otherwise, you can use the default file system. For example, I need some distributed file system, and then you can purchase it. So it can be provided by the modular, sometimes free, sometimes not. So Solaris actually start the first time such a modular strategy. So that causes sometimes problem. People expect, those who are familiar with the Microsoft style operating system, actually when you purchase the Sun Solaris system, they expect their Sun Solaris include everything, but now you need to pay more to get the file system, for example, or the other system core, system library. You need to pay by the module or even the program compiler. You need to pay. Really. So, however, because of the GNU product or for example, when you purchase the Sun Solaris, they do not provide a compiler, C compiler. There is no CC. So you need to pay and buy that compiler. However, you can use GCC, GNU compiler, C compiler. That works exactly same as the Sun Solaris, the compiler. After that, they try to provide sometimes free. However, nowadays they mix and hybrid is one of the trend, right? So they try to get the benefit of this one, the modular and layer approach. So it's a hybrid system. For example, Mac OS is a hybrid. It has a layer or the different. This is slide to show the Mac OS the structure. Okay, for the graphical user interface, it uses Aqua. It's been a long time to has been developed such an Aqua interface, and also it has. This is hardware level. That is the user level, the interface. So these are the kernel environment. It's a based on microcontroller, but also again the Berkeley. The branch Unix side. Yeah. So iOS is the sub-branch of the macOS. Then there is only for specifically for the iPhone and iPad. Okay. In terms of structure, it's the same as the OS X, but in terms of application, that's not comparable. Okay, even though they are from the same branch. course, they use a different CPU, different hardware. I'm not very good at, I didn't, do we have any programming class for iOS? Kind of. I heard that Professor Dicta teach the Android application.
It's supposed to be one semester Android and one semester
I
iOS.
see. Okay. So Android is also another. So nowadays the iOS and the Android two major operating system in the smartphone. Okay. Portable device. I think the portable device is better. I don't like the name of the smartphone. It's really smart. And it's based on the Linux kernel, as you know. Okay. And also it has the Java plus Android API. So if you know the Java very well, it's not a big deal to learn the Android programming. So especially, so you are still use the Eclipse IDE for Android programming. And also it provides some framework for web browser or the database, the SQLite, and the multimedia, so you can easily do your program. Also, it has an emulator, so you don't have to purchase the real device to develop the program. You can use such a emulator based on the big virtual machine. So this is the architecture of the Android operating system. It has something library, system library, and this is kind of kernel runtime. Also, operating system requires the debugging when it has been developing. So it has the debug. For example, dtrace. So using the dtrace, you can debug the process tree. You can not find the problem of your operating system from one process. You need to investigate the process tree. At the time, dtrace is the one application to the track problem of the process tree by the system function, each system function for the each system, and so on. And also it's a user mode or kernel mode. And also, as we are doing, so we can use the task manager for the performance tuning. Then finally, after you design and implement, you can apply it to the real system. How can we apply that? We need to create a kernel program. That is operating system generation. So there are specific programs to create a kernel like the system. If I have a time, I'd like to have an exercise lab to create the kernel using the educational purpose operating system provided by the MIT and some university use that. Unfortunately, I didn't have a time for this semester, so we will cover that part. But if you are interested in such a kernel rebuild, I will give the reference site and link, then you can do it by yourself. So you need to the only requirement is you need to have some basic assembly language programming. I think that if you already took the microprocessor and PCHARD course embedded system, I think pretty much enough to do the exercise lab by yourself. But probably I'm not going to teach this course the next semester if we have the new professor who is expertise on the operating system. Pretty much the new professor will take this one. Okay. So this is the end of chapter 2. So I posted the very simple homework. So when is the due? Tomorrow. I don't think it takes time, just the couple of minutes. It's just for your remind. There are students who keep copying and pasting the others, so please, it's just for your understanding and for your study. So please, complete your homework by yourself and submit to the Canvas. I'm not going to accept any email submission, but you can ask the question if you have the to the GA or me. But your submission should go to the Canvas. Okay. Any other question? Okay, so we will see the next week, Monday, Tuesday? Tuesday. Okay, thank you. And also, I'm not sure whether I posted the PDF file. It's a